Hello everyone. Today I thought I'd make a video to break down subnetting. Now, I know we covered this in class, but let's go over it again more slowly this time just to make sure it really sticks. But before we get started with subnetting, it's important that we understand four key topics. That's binary conversion, CIDR notation, power of twos, and finding your increment. Once we've mastered these four topics, subnetting becomes much easier. So let's get started. We're going to start with binary conversion. Here I have four octet place value charts to help us with our binary conversion. Remember, each octet has 8 bits. Each number represents a place value or a power of 2. Every bit can be on or off depending on whether we use that value. Let's walk through a binary example by converting the decimal number 75 to binary. And we're going to do it in this octet right here. Okay, this is the last one of a class C. So we're going to do it in this octet. So we start off by asking ourselves, can 75 take away 128? If the answer is yes, we would turn on 1 bit. If the answer is no, we're going to put a 0. And 75 indeed cannot take away 128, so we're just going to put a 0 here. Now we're going to ask ourselves again, can 75 take away 64? Yes, yes indeed, 75 can take away 64. And since that's the case, we are going to turn on a bit. Now, once 75 takes away 64, we're going to, let's put it here, 75 take away 64, and the answer is going to be 11. So now we're going to ask ourselves, can 11 take away 32? That's a no, so we're going to put a 0 there. Can 11 take away 16? Nope, so we're going to put a 0 there. Now, can 11 take away 8? I think so. 11 can take away 8, so we're going to map that, and 11 take away 8, we're left with 3. So 11 can take away 8, so we're going to turn on 1 bit here. And now we're going to ask ourselves, can 3 take away 4? 3 cannot take away 4, so we're going to put a 0 here. Next, we're going to ask ourselves, can 3 take away 2? 3 can indeed take away 2. Right? And when 3 takes away 2, we're left with 1. We're left with 1. So we're going to turn on 1 bit because 3 in fact takes away 2. Now we have to ask ourselves, can 1 take away 1? And the answer is yes, 1 can take away 1. And we're left with 0. We're going to turn that 1 bit on now. And there you have it. This is how you perform a binary conversion. You keep going down in the similar pattern until you reach 0. Okay? And just so that it's clear, 75 in binary is equal to 0, 1, 0, 1. Oh, I made a mistake there. I need to look at my chart. That's why it's good to have a chart. Sometimes you get in the hang of singing the bits. So you don't want to do that. Just going to put 0 there, following our chart, and yes. And that's 75 in binary. You can follow this method again to convert any number in binary. Okay, so think we can say with enough practice, we can master binary. Check. Okay, so what we're going to talk about now is CIDR notation. So here we have 3 subnet classes. A class A, which only has 8 bits on in the first octet, and that think about think about think about it here. We have 1 octet, 2, 3, 4, right? So if I turn on all the bits here, we can see 1, 1, on, oh, okay, because it's in there, I can't change it. So I'm going to turn all of them on, on, on. And if we tally 1, 2, 4, 8, 16, 32, 64, 128, you can see that we would get the answer of 255. And that's how you revert binary to decimal. And since we have 8 bits turned on here and everything else is off, in this example here, we have a /8. A class A subnet would have a default /8. CIDR notation with 8 bits on. A class B would have 8 in the first octet, 8 in the second octet, and 8 plus 8 equals 16. So we would give it a /16. A /16, right? And then we would just write 1 here, 1, 1, 1, 1, 1, 1, 1. And all bits are on here, and that's our /16, our class B subnet mask. Now we have a class C, and we have 8 on in the first octet, 8 on in the second octet, and 8 on in the third octet. And so what we have now is we need to turn on all of these bits here. So we just tally them up, and it would result in 255. And we have the answer here. Turn on all the bits and revert them back to decimal, and we would get the answer 255, 255, 255. Okay, so that's how we get our CIDR notation. We're just counting the number of bits, the network bits that are on. And sometimes we might want to divide a Class C network. And in order to divide a Class C network into multiple networks, we would use subnetting. And in subnetting, where we would borrow bits. So, as an example here, you see it's slash 25. What does that mean? That simply means, okay, so this is our default Class C. All of the bits are on. We can turn one more bit on here, and this would be 8 plus 8 is 16 plus 8 is 24. That's our default 24 right here. And if we turn one more bit on, we would have 24 plus 1 equals 25. And that's what we have over here. In this example here, we have 25 bits on. And for that example, if there's 25 bits on, that means we have everything off. Just going to put a 0. Okay, now that's what we're talking about when we say a CIDR notation. We're just counting the number of network bits, right? We're counting the number of network bits, and they may increase beyond beyond their default class, and we perform subnetting to increase the network bits and to divide them. Okay? So now let's go to the power of 2's. So we went over binary. Just going to erase this. We went over binary. We're going to erase that. Now we're going to talk about the power of 2's. Why is binary based on the power of 2? Because each bit doubles the number of possibilities. That's why our chart is 128, 64, 32, 16, 8, 4, 2, 1. Each one is just 2 raised to a power. Here we can see 2 is raised to the power of 7. 2 is raised to the power of 7, and that equals 128. 2 is raised to the power of 6, and that equals 64. 2 is raised to the power of 5, and that equals 32. 2 is raised to the power of 4 here. That equals 16. 2 is raised to the power of 3. That equals 8. 2 is raised to the power of 2. That equals 4. And 2 is raised to the power of 1. And that equals 2. 2 then is raised to the power of 0, and that equals 1. Remember, anything raised to the power of 0 is 1. Now that we understand the power of 2's, we are going to come back to this and use it in network formulas and host formulas, but it's coming. Now let's talk about the increment. The increment tells us where each network starts and ends. So the increment just tells us the range between each subnet. For example, let's say we have a slash 26, and that would equal 255 25 dot 255 dot 192. How do I know that's 192? Well, think about it. If we have 255, if we have 255 on here, that means all of the bits are on. In the first octet, the second octet, the third octet. So this is just a default class C, and which would have 24 bits on by default. This means we have an extra. I'm going to go to my octet chart now. An extra 2 bits on. So I'm going to mark that. Mark that. Mark my 2 bits. One here. So we have 2 extra network bits on. The rest would be 0. So upside down heart. How did I do that? Okay. I did it again. It's not even Valentine's. Okay, so try it again. Let's go. Okay, and we have a 0 here again. Another 0. Another 0. Another 0. And another 0. Yeah, I'm not gonna. Definitely do not put a heart here. I'm trying this new stylus. This is crazy. Okay, so the SATA notation really helps us in the conversion. It just turns on 2 extra bits to make 26. And those are the 2 extra bits here. And if all of these are on, we have 24. And 24 plus 1 is 25, plus another one is 26. And when we combine 128 plus 64, we get 192. And that's how we get our answer of 192. So binary conversion is the key to subnetting. Okay, so now we need to find our increment, and our increment in this example will always be the last bit. And our last bit is here in 60 in the 6th place value here. Let's just say it right here. And using the power of 2, it's 64. That means our increment is 64, and our networks are 0 to 64, 128. We're just adding 64, 192. We're just adding 64, right? So we're just adding 64. And here, we're just adding 64. So we're going to stop there. And that tells you the increment. The increment here is 64. So that explains how we're going to increment our subnets. Okay, so now I think we have a strong foundation for subnetting. So let's try and subnet. Let's clear the board. Okay. In our example here, we have a class C with a /25. /25. What that means is we have 25 network bits on. So let's mark it 1, 2, 3, 4, 5, 6, 7, 8. This is 24, right? Plus one more, and that's going to give us 25. That gives us 25. That explains our /25. Okay, right, our /25. Okay, the first step is we are going to convert. We find the last octet, right? And it's this one here. We're going to convert this into binary, okay? And it's going to look like this. 1 bit is on, 28 take away 28, 128 take away 28 leaves with 0, so everything else below it is going to be 0, 0, 0, 0, 0, 0, 0. So what we're looking at here is basically this. Okay, great. So now that we have that, our next step is the power of 2's, right? So we have here, we can see we have 1 bit on, 1 network bit on, and 7 host bits on. Using the power of 2, we can we can use this formula to, let's say, right, let's raise it here. 2 to the power of 7 host bits, take away 2 gives us 128. 128. And remember, we can't use everything inside here because we have to reserve the network address, and we can't use the broadcast address. So we say 2 raised to the power of 7, and again, 2 to the power of 7 is 128. Take away 2 equals, oh, sorry, it's actually, yes, 126. Yes, we minus 2 because we can't use the network bit and the broadcast. Knowing what we know now, we can start plotting our IP address range because we have an RIP. We can start, so now we can put our numbers in. Actually, no, we do have another power of 2 formula where we can find the number of subnets. So here we're going to say 2 to the power of network bits, and there's only one network on, and that equals, if we go over here, 2 to the power of 1 equals 2, and 2 to the power of 1 equals 2. So that means we have 2 subnets. We have two subnets. Okay, so now, and we know our increment is 128. Our increment is 128. Our usable host is 120 increment. Usable hosts. And since we have a 0 in our first ID, that would be the first network ID. That's our network. The first usable will definitely just be 1, which is the next number. Our last usable is 126. 126. Our broadcast would be, and then we would start our network ID. Okay, yeah, we can just erase this. Everything stays the same except for the last one, right? Oh, no, let's erase this again. Ah, come on. I'll just leave it. Right, so we have 128. First usable is 129. 4, 255. And there you have it, subnetting. So with a subnet, with a slash 25, we took one class C subnet and split it into 2 subnets with 126 hosts each. So to wrap up, let's recap what we've learned today. We've learned how to do binary conversions. We've learned about CIDR notation. We've learned about the power of 2's and the formulas to calculate the networks and hosts. We've learned about the increments. And finally, we've plotted the range for a slash 25 network, which also allows us to answer questions on the exam like which subnet would this IP address be on? So they'll probably just give you a random IP address. You can definitely say this IP address is not in the first range because we can see the first range starts from 0 and it goes to 127. This IP address is definitely in the second subnet because the second subnet starts from 128 and it goes to 255. So this IP address is in the second subnet. So you may have another question on the exam, which asks you to figure out why a device is not communicating properly, and then you need to check the network adapter to see what IP, just to run the IP config to get /all to get all the information that you need, or you can manually go into the graphical user interface to see the network adapter and check to see if there are any static IP addresses. Normally, sometimes when there is no communication, it might be a conflict in IP address scheme in terms of invalid gateway, invalid IP address. So this is why we need to check. Once we check, and then we should be able to answer the following questions based on just filling out these questions. Thank you for watching, and I appreciate your patience.